Hello again, this is Steve with SSI. Welcome to the shop. Today, I want to go over something that I've been asked a lot here lately. And it's probably a good thing I just do this on one of the shows and I can at least refer people to this. Today, I want to talk about bolt patterns. So I'm not going to machine anything. I'm not going to drill any holes, any of that kind of stuff. I'm just going to walk you through the math that I use. There's other ways to do this, of course, and their ways aren't bad. This is just the way I know. So today I'm going to do for you a 5-hole bolt pattern on a 2-inch diameter circle. This piece of material I have in front of me here, this grid paper, is going to represent the milling machine as far as the table. So got X positive, X negative, Y positive, Y negative. And in the center is going to be our 0, 0. So if you have a milling machine with a DRO, the piece of material will be XY0 as far as the material itself goes, whatever you have here in the middle. But for our purposes, or for my purpose here, I'm just going to use this sheet of paper to resemble the table. Now the method I use to figure out bolt circles, it's a tried and true method. The Machinery's Handbook has it in it. And speaking of which, the Machinery's Handbook has A patterns and B patterns, and they use XY0 in the center of the part for the bolt circle pattern. Now you can go to the Machinery's Handbook, and the math is in that book. You just kind of have to decipher a little bit of it. I'm going to do it here. Then I'm going to plot out the bolt circle pattern right here on this grid paper so you can see it. And using grid paper like this a lot of the time, I do that a lot. Just to map out something that I'm trying to do, or if it's a complicated procedure, then I can put all my XY coordinates along the perimeter of the piece that I'm doing, do a little rough sketch and put it on there, and it helps out quite a bit. Like I said, I do it a lot, but the method that the Machinery's Handbook has in it, if you want to do the math, longhand, is we're going to use the 0.5 sign, and in the brackets there is degree, and the 0.5 cosine, and the degree is also in the brackets again. Now if you've got a scientific calculator, it makes this a lot easier than trying to figure out how to do it with a standard calculator. So whenever you type it in, it should look very similar to that. So 0.5 cosine, you have a bracket, you put in the degree, close the bracket, and hit equals, and it gives you a tally of whatever that is. So when we're talking about cosine and sine in the bolt patterns, the sine portion of this is going to be X. And the cosine, of course, is going to be just the opposite. The cosine, of course, will be Y. So, of course, you'll have X that comes over so far and Y that comes down or comes up, however it's going to be. And that's going to be the plots for the bolt pattern of where to drill. So the first thing we have to do is we have to assign sine and cosine to different degrees of whatever that degree is going to be. So if we have a 5-bolt pattern, we're going to take 360, divide it by 5, and that gives us 72 degrees. So from the first hole being 0, 0 to the next hole is 72, Then the next hole after that is going to be 72 plus 72. Then it's going to go on to hole number 3 at 144. Plus 72 will be 216. Plus 72 will be 288. Then it'll go plus 72. Then it'll go back to 0 again. So the whole thing about it, it's 72 degrees between holes. So let's take a look at some numbers that we get whenever we do the math for this. So 0.5 sine in the brackets is 0 degrees, and that gives us the answer of 0. Our next one is 0.5 sine in the brackets will be 72 degrees, and that's going to give us the answer of 0.4755. And we just keep going on down the line. So next one will be 144 is 0.2938. 216 is negative 0.2938. And 288 is negative 0.4755. And you'll see this happen a lot when these hole patterns, because of course they flip and go to the other side of whatever relative that they're on, X or Y. So they'll be positive, then they'll go negative. Now this is just for X. 0.5 sine is for X. So now we do go back and do Y, and it's going to be 0.5 cosine 0 degrees, and that gives us the answer of 0.5. Then 72 degrees is 0.1545, negative 0.405, negative 0.4045, negative 0.4045, and for 288 is 0.1545. Same kind of pattern goes around. So what do you do with these after you've done your two columns? That's usually how I'll lay it out on a piece of paper, as I'll do two columns just like such, X and Y. Well, this is just a starting point. So once you do this for each one of these hole patterns, you can keep this little card kind of handy, because these numbers will never change. What happens is you have to multiply these numbers against whatever diameter of hole circle that you're going to do. So in this particular instance, I'm going to do a hole circle of 2 inches. So each one of these, 0.4755 on down the line for X and Y both, is going to be multiplied to 2. And that will give me the actual XY coordinates of where to drill on my part. So let's take a look at that. So now that they're all multiplied to 2 inches, this is the outcome. This is the payoff right here. So hole number 1 is going to be 0 degrees and 0 degrees. So 2 times 0 is 0, and 2 times 0.5 is 1. And on down the line. So hole number 2 will come in at 72 degrees. 3 is 144 degrees. Hole 4 is 216, and hole 5 is 288. They're all 72 degrees away from each other for 5 holes in 360 degree circle. They've all been multiplied to 2 inches, X and Y. So what I'm going to do is I'm going to pretend that each one of these little squares is 100 thousandths away from each other. So this will not be to scale. And I'm going to do hole number 1 and plot it here on my little piece of grid paper. So this is my starting point, 0, 0, in the middle of whatever circle that we're going to have. I'm going to move X is going to be 0. So no movement in X. But in Y, I'm going to move positive 1 inch. So there's hole number 1. So hole number 2 is going to be X positive 951 thousandths. So I'm going to go positive X. And there's 9. There's going to be about a half, about right there. I'm going to go 309 positive and Y. 1, 2, 3. About right there. Hole number 3 is going to be 587,000/6 in the X position, so X positive. And it's going to go negative 809. So there's that hole. So that's the third hole. Notice it's going in a clockwise rotation. Now we're going to go to the other side of things. For hole number 4 is going to be negative 587/6. And back down to negative 809. Coming out pretty good. And the last one, hole number 5, 288 degrees, so it's negative 951 and positive 309. So negative on the X, 951. About right there. 9, 2, 3, so about right there. So there it is. There's the 5-hole pattern. Now the beauty of this little system that I really like is, let's say somewhere in here, and the Machinery's Handbook doesn't do this for you. You have to figure it out on your own. Now if I want to put a hole, say between holes 4 and 5, that's where this comes in. So you can do just one, just like such. So it's going to be what, 36 degrees, so it'll be like 252, right? So 252 degrees. We've done a little bit of math there, multiplied it to our 2-inch, and now we're going to be putting in our X and Y coordinates here. So we need to go negative 951 and positive and negative 309 in Y. So let's see what that does. That right there. 1, 2, 3, 09. That right there. So that's between hole 4 and 5, right in the middle, in this nice circle. So if we wanted to go half the distance all the way around, then you could just use a 10-hole pattern. Wouldn't be no big deal. Or if you know how the hole pattern system works in Machinery's Handbook, then you could just go to the 10-hole pattern, pick out which one would be between 4 and 5 in your 5-hole pattern, and that would be the coordinates right there. Now let's say the Machinery's Handbook goes from 3 holes to 33 holes. If you've got a 38-hole pattern, well, then you're still going to have to do some math. So it still works. This system works very well, and I've used it for a very long time. In fact, this is the only way I normally do this. I know a couple of people that trig one out using right angles, a triangle. That's no problem. Works for you, that's great. There's Other people have other systems. You can also use an app that's on your phone, I'm sure. Another easy way to do it. But if you don't have an app, or if you just got what you keep in your toolbox is just a scientific calculator. They even have machining calculators nowadays that you can do this and it'll spit it out for you. But this is the way I've always done it. It always works well. It's always done me well. I thought I would go over it, give you a little bit of an idea how I do it, in case anybody had any questions. I know the little cards and writing may be a little bit old school. Like I said, that's just the way I do things. Do the math longhand, check it. I'll grid it out on a piece of paper so I know what it looks like. And if I know, I'll know if a number is way off, if it winds up over here or down at the bottom of the page or something. If you're going to make a mistake, it's usually going to be a large mistake, and you sure don't want to do it as you're drilling. So the biggest takeaway, other than the math on how to do this, is get you some scrap paper, get you some grid paper like I've done here. So I keep a lot of this around. It really helps whenever, keeps you from making mistakes on the machine, and that's one thing that we don't want to do. We don't want to scrap parts because it's time consuming and costly, and it doesn't feel good. So I hope you guys use this a little bit, and I want to thank all my subscribers and all the people that help make this happen for me. I do appreciate your time, and thanks for watching.